Hello, this video is titled Topic Recap on Giant Covalent Structures. In particular, we're going to look at graphite and graphene. We will recap what simple covalent molecules are. We will recap the basis of giant covalent structures, and then we will specifically talk about graphite and graphene and what the GCSE style questions look like on those topics. So first of all, giant covalent structures and simple covalent molecules. So the pictures here are simple covalent molecules, your Venn diagrams, so things like water, your diatomic elements. Simple covalent molecules, they're the ones that have weak intermolecular forces existing between them. They've got low melting and low boiling points. These here are your giant covalent structures. So you'll see on one of my previous videos we've spoken about diamond and silica dioxide. We're now going to talk about graphite, okay, and then off the back of that we're going to talk about graphene. These are giant covalent structures. They have very, very different properties to the simple covalent molecules. So first of all, graphite. This is a classic picture here of graphite. If you type graphite into the internet and ask to look at its molecular structure, you will see pictures like this. So pay attention to each individual carbon atom. Remember, all of these giant covalent structures that you learn about, apart from the silicon dioxide, are allotropes of carbon. Allotropes means a different form of carbon, okay? So each of these here is a carbon atom, okay? So carbon atoms, remember, 4 electrons in their outer shell. So each of those is a carbon atom, and you will see, obviously this diagram is just a small kind of snapshot of the graphite, but in theory this lattice continues. So each of these carbons then go on and bond to somewhere else. Okay, so I'm just drawing bonds here. In theory the bonds carry on, and each of the individual carbon atoms are bonded 3 times. So they bond one, like if you take this one here, it's bonded 1, 2, 3 times. Okay, so it means that 1, 2, 3 of its outer shell electrons are engaged in pairing, which means consequently that we have a free electron in the outer shell of carbon, and that's going to come into play later on. Okay, so only 3 out of the 4 electrons are involved in covalent bonding, and there is no covalent bonding between the layers. So graphite is lots and lots of layers of this structure here. Okay, so that's 1 layer, that is 2 layers, okay, and between each of the layers you can see here these not covalent bonds, these intermolecular forces, okay. And it's very important, like the mistake I just made there, they're not covalent bonds, they are intermolecular forces, which is why they're represented as a dotted line, okay? And we know already that intermolecular forces that exist between simple covalent molecules, they do exist in giant covalent structures, but only in something like graphite, and they are very, very weak intermolecular forces. Again, that will come into play later on. So in graphite, you have got 2 types of bonds and forces. You've got the covalent bonds between each of the carbon atoms. You've then got the intermolecular forces that go between the layers. Covalent bonds, very strong. Intermolecular forces, very weak. Okay, remember we've only got 3 electrons in the outer shell of carbon are bonding, which means we have 1 free. So first of all, we take graphite's first property down here. Graphite is soft and slippery. So the graphite layers, these layers can slide over one another. Okay, so 1 layer will go one way and 1 layer will go the other. They can slide, and the reason they can slide is because these intermolecular forces are really weak and they're very, very easily broken. Okay, and that's why graphite is sometimes used as a lubricant. Okay, so like if you've got a creaky door and you spray a lubricant on it, it may well be that graphite or some form of graphite is in that lubricant. Okay, the layers are able to move over one another because of the weak intermolecular forces, so it gives graphite this property of being described as soft and slippery, and you'll see that phrase come up in your GCSE exam questions, and it's why graphite is a lubricant. Okay, now the delocalized electrons that I spoke about give properties of graphite. Give the two properties of graphite: thermal energy conduction and conduction of electricity. Graphite is the only non-metal that will conduct electricity. Okay, so the delocalized electrons, they are able to move throughout the structure, okay, and they then can carry charge, okay, and in the same way that those delocalized electrons can move throughout the structure, rather than carry charge, they can also gain thermal energy, and it means that the whole structure of graphite can also conduct electricity and also thermal energy. Okay, so remember, think back to things like diamond and silicon dioxide, which are also giant covalent structures. They didn't conduct electricity because they didn't have the free moving electron. Okay, other properties of graphite will include things like talking about why it might have a high melting and a high boiling point. Again, that just comes down to the fact that one, it's a giant structure, and two, the fact that there are lots and lots of strong covalent bonds. Okay, so giant covalent structures will tend to have those similar properties. So when I talk about each individual structure, I might not always refer back to things like hardness or high melting and high boiling point. But remember, if you've got a question in terms of graphite on high melting and high boiling points, a giant lattice or giant covalent structure, lots of strong covalent bonds which require lots of energy to break. That is graphite. We now come on to graphene. Now, graphene is essentially just one layer of graphite, okay? So this is a fantastic element. It was actually, a fantastic giant covalent structure was actually discovered here in the UK at the University of Manchester, and its applications at the moment are still fairly widely unknown. If you type graphene into the internet, you'll find lots of current research going on about graphene. Okay, the reason graphene is so it has so many different properties is the fact that it's one atom thick only. Okay, so this is literally just a single layer of graphite, and I think from what I remember when I read the research at the time, the idea did literally come from using sellotape and just peeling off a layer of graphite using sellotape. Okay, so therefore the properties of graphene are therefore almost identical to graphite in the sense that it conducts thermal energy and electrical energy, and it's a very, very good conductor because, again, each of the carbon atoms, remember we're still talking about carbon here, each of these carbon atoms bonds 3 times. So remember I drew my outer shell of carbon. Okay, 3 of the electrons are involved in bonding, which leaves 1 spare. Okay, that 1 spare becomes delocalized. Okay, keyword there, delocalized. It means that graphene, just like graphite, can conduct heat, thermal energy and electrical energy as well. It has a very low density, very, very low density. The reason being, it is literally 1 atom thick, and it's a very, very reactive form of carbon. Again, with graphene, you will see other properties. It's not soft and slippery like graphite is, okay, because there's only 1 layer. Graphene can be described as being incredibly hard. Again, the reason being, it's a giant lattice, a giant covalent structure, lots of strong covalent bonds, require lots of energy to break, which is again, leading on to the fact that it has a high melting and a high boiling point. So graphene, far better than graphite in the sense that it's just 1 single layer, so therefore it has a low density, and it's very, very reactive form of carbon. Okay, remember it still has delocalized electrons, the reason being only 3 of the outer shell electrons of carbon are involved in covalent bonding. Now we're going to look at some GCSE questions. First of all, I've got graphite here. So 2 key properties of graphite. See there I said about the wording soft and slippery. Okay, and also why graphite can conduct electricity. And look at the number of marks these hold. Okay, So lots of these questions are, obviously you do get 1 mark multiple choice questions on giant covalent structures, but lots of them are like 2, 3, maybe 4, 5 marks. There are 6 mark answers as well, okay? They can really hold some heavy weight in terms of marking, okay? So this is graphite, asking you to use figure 2. I'm going to go through all the questions in the sense that I'm going to read them to you, show you some key points, but then I would suggest that you pause the video and wait for the mark schemes to come up. These are 2 questions about graphene. So again, explain why graphene is strong and why graphene can conduct electricity. So the conduction of electricity here, remember, think back to what I said about the outer shell electrons. Graphene is strong. What type of structure is it? And look, what kind of structure is it? And here it's saying use your knowledge of bonding. Okay, and not only does it say use your knowledge of bonding in terms of this question, but it's saying bonding in graphite. Why is it asking you to think about graphite when we're talking about graphene? Because remember, graphene is just a single layer of graphite. So you can use what you know about graphite to talk about graphene. Okay, so if you want to answer those questions, pause now. I will then let the video carry on, and I'm going to talk you through a couple of key points on the mark scheme. Okay, so first question then, this was why graphite is soft and slippery. So it contains layers. Remember, the layers have weak intermolecular forces between them, so the layers can slide. 3 marks. Conduction of electricity, also the same as the conduction of thermal energy, delocalized electrons, okay? Remember, these electrons must be described as being delocalized. They can then move throughout the whole structure. We then came on to graphene and why graphene is strong. It's a giant lattice, giant covalent structure. And to be honest, if you'd said giant covalent structure, you automatically get the first 2 marks. And remember, you say covalent bonds are very strong or they need a lot of energy to be broken. Again, 3 marks straight away in a very simple sentence. And the last one, why does graphene, like graphite, conduct electrical energy? Remember, delocalized electrons, they can move throughout the entire structure. Notice how that's underlined there. So that video was on graphite and graphene, plus we've also spoken through some GCSE style questions. As always, rewind the video, rewatch it, have a go at those questions yourself. Good luck.